numerator by denominator, what will be the remainder? All the questions will be of the form numerator by denominator, what is the remainder? So there are two cases possible. There are two cases possible. Numerator and denominator are co-prime to each other. Numerator and denominator are co-prime to each other. Are co-prime to each other. Are co-prime to each other. Numerator and denominator. That means HCF of base in numerator, HCF of base in numerator, comma denominator. It is nothing but 1. Two numbers are said to be co-prime to each other if their HCF is 1. Two numbers are said to be co-prime to each other if their HCF is 1. If numerator and denominator are co-prime to each other, there are multiple ways. One is a negative remainder concept. One is a negative remainder concept. And another is an Euler's theorem concept. Euler's theorem. Yesterday we discussed all this. Next one will be Chinese remainder theorem concept. Chinese remainder theorem concept. Next one will be Fermat's theorem concept. Write down in the same way. Write down in the same way. One is a negative remainder concept. Another is an Euler's theorem concept. Chinese remainder theorem concept. And the last one, it is a Fermat's theorem. Last one, it will be Fermat's theorem. When the Fermat's theorem is used, when the denominator, it is a prime number. When the Fermat's theorem will be used, when the denominator, it is a prime number. When the denominator, it is a prime number, Fermat's theorem is used. When the Chinese remainder theorem is used, when the denominator, it is a composite number. When the denominator, it is a composite number. If the denominator, it is a composite number, then the Chinese remainder theorem is used. A prime number is a number which is only divisible by 1 and itself. Which is only divisible by 1 and itself. Chinese remainder theorem is used when the denominator, it is a composite number. A composite number is a number which has got more than two factors. More than two factors. There are three kinds of numbers based on factors. There are three kinds of numbers based on factors. Based on factors, there are three kinds of numbers. Only one factor. Only one factor. If there is only one factor, then the number is called 1. If there are only two factors, if there are only two factors, if there are only two factors, then the number is called a prime number. Then the number is called a prime number. If there are greater than two factors, if there are greater than two factors, then the number is called a composite number. Then the number is called a composite number. Depending upon the number of factors, there are three kinds of numbers. A number which has got exactly one factor. A number which has got exactly one factor. That number is called 1. 1 is a factor for every number. 1 is a factor for every number. Number which has got exactly two factors. The numbers which has got exactly two factors, that is 1 and itself. 1 and itself. Numbers which has got exactly two factors are called prime numbers. A composite number is a number which has got greater than two factors. Numbers which have got greater than two factors are called composite numbers. Numbers which has got exactly two factors are called prime numbers. Only on prime numbers in my paid batch I will discuss 6 to 8 hours class so that a student will understand all the 15 to 18 models of questions that can come in prime numbers. Numbers, the classification of numbers based upon factors. Only one factor, only two factors and greater than two factors. So, negative remainder is used when the denominator can be either a prime number or the denominator, it is a composite number. Negative remainder can be used when the denominator, it is a prime number or the denominator, it is a composite number. Denominator, if it is a composite number, I will use Euler's theorem also. I will use Euler's theorem also. Listen carefully to the next few lines, whatever I am saying. If you are unable to solve the problems in less time by using negative remainder concept, if the denominator it is a prime number, then make use of Fermat's theorem. If you are unable to get the answer by using negative remainder concept, when the denominator it is a prime number, use this concept of Fermat's theorem. Step number 2. If you are unable to find the negative remainder concept, when the denominator is composite, go to Euler's theorem. If that is also not giving you the answer, then go to Chinese remainder theorem. Then go to Chinese remainder theorem. This table is of extreme importance to me. If you understand this table, entire reminders chapter will be extremely clear to you. Again, I am repeating this point. If the negative, I will put it in a next slide. All the remainder based problems will be of this type. Either the denominator can be, there are only 3 cases possible. If the denominator it is 1, then it is called a natural number. 4 by 2 can be optimized as 2 by 1. 6 by 2 can be optimized as 3. 8 by 4 can be optimized as 2. If numerator and denominator are co-prime to each other, if the denominator it is 1, then it is called a natural number. If the denominator it is a prime number. So we are first understanding what are all the cases that can be possible for a denominator. Denominator can be 1. If the denominator is 1, then it is called a natural number. If the denominator can be a prime number, denominator can be a composite number. So 2 cases will arise. What will happen if the denominator is a prime number? What will happen if the denominator it is a composite number? Denominator it is a composite number. See here, sir. Reminder. Slowly, concept by concept, not a single doubt, you will get it in the class. Numerator by denominator. If the denominator it is a prime number, if it is a prime number, first use negative reminders. If you are able to solve it very quickly by using negative remainder, stop it. If it is taking more time, then go to Fermat's theorem. This is an extremely important slide, sir. If the denominator, if it is a composite number, first try to solve using negative remainder. If it is not giving you answers in shorter time, use Euler's theorem. If it is also failing, then use Chinese remainder theorem. Please put it as very, very important slide, sir. Very, very important slide. This slide will tell you when to use which concept. Very, very important slide. If the denominator it is a prime number, first I will check with the negative remainder. If it is taking more time to solve a question, then we will get into Fermat's theorem. We will solve first by using negative remainder. If it is taking more time, then I will get into Euler's theorem. If it is also taking more time, then I will get into Chinese remainder theorem. Now, yesterday's class, we did this and we also did this. Now we will continue with the next. What is Euler's theorem? Euler's theorem states, Euler theorem is used to find out the remainder when you divide a number by composite number. A power phi of n by n, it is 1, where a and n are co-prime to each other, where A and N are co-prime to each other, and the denominator, it is a composite number. Denominator, it is a composite number. Any composite number can be written as power of prime numbers. P1 power X, P2 power Y, P3 power Z. So what do you mean by totient of N? Totient of N. Totient of N is nothing but N into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3, 1 by P3. We have seen yesterday this case, and we have done a lot of problems where the denominator, it is a composite number. Where the denominator, it is a composite number. Now see here, we will take up Fermat's theorem. Fermat's theorem. The difference between Fermat's theorem and Euler's theorem is, Fermat's theorem is used when the denominator, it is a prime number. Euler theorem is used when the denominator, it is a composite number. N is a prime number. N is a prime number. If N is a prime number, if N is 11, this can be written as only 11 power 1. If N is 29, this can be written as 29 power N. So the quotient of a N, which is a prime number, quotient of a prime number, it is nothing but, N is nothing but P1 into 1 minus 1 by P1. So any prime number can be written as a singular power of a prime number. 23 can be written as 23 power 1. 31 can be written as 31 power 1. So P1 into 1 minus 1 by P1. These are nothing but P1 minus N. Very, very important point. Please write down. Quotient of a prime number. Quotient of a prime number. It is nothing but prime number minus 1. Prime number minus 1. Take the quotient function of a prime number. Quotient function of a prime number is always given by prime number minus 1. How you got prime number minus 1? Here the N is a composite number. Here the N is a prime number. Any prime number can be written as a singular power. 11 can be written as 11 power 1. 29 can be written as 29 power 1. So P1 can be written as P1 power 1. So it is nothing but P1 into 1 minus 1 by P1. P1 cancel. Answer is nothing but P1 minus 1. P1, it is a prime number. Very, very important key point. So in Fermat's theorem, if N is a prime number, it will become a power P minus 1 divided by P, it is nothing but 1. A power P minus 1 when divided by P, it is nothing but 1. Where P is a prime number. Where P is a prime number. Very, very important concept. The difference between Euler theorem and Fermat's theorem is, Euler theorem is used when the denominator, it is a composite number. If the denominator, it is a composite number, Euler theorem is used. Fermat's theorem is used when the denominator, it is a